Hello, everyone. Let me introduce ourselves while we're getting started. I'm Carla. I'm the marketing manager here at Fuse Forward. This is the 6th remote control webinar we've done in the series. This is a really interesting topic today, digital innovation in challenging times. We have Ray Jung, our solution architect with Fuse Forward, solution engineer. He'll be just talking about the challenges facing critical service providers and looking at innovative ways of addressing them using a cloud-based disaster recovery service. We also have Chris Franco from CloudEndure on the call today, so we're happy to have him here, as well as Daniel Covey, and they will be talking about CloudEndure, how it works, and taking a look at some of the more details around that. So I won't take any more of your time. I'll hand you over to Ray. Thanks.
Thanks, Carla. Good morning, good afternoon, good evening, wherever you reside. We're talking today regarding the digital innovations in challenging times. So what is really driving digital innovation? One of the first points that is shown here is mandate to decarbonize. Some states in the east coast of the US are actually mandating that power utilities be produced using a less carbon footprint, either using wind, solar, or some form of renewable energy, or by utilizing some form of carbon capture to offset the carbon footprint. Another point that is driving digital innovations is the customer demand for online services. So customers are actually looking for more personalized services from utilities, what they're accustomed to when they receive from like retail or banking, and they're looking at how they can consume less or save more money or so to speak regarding their utilities. The third point, pushing towards remote workers. As we've seen during these times during COVID-19, a lot of work has been pushed back to remote work. So it's a little bit more adjustment from the utility standpoint, because some people who can work from home have been pushed home, whereas there's other workers who either need to be on site, or they're part of a field crew that need to be dispatched. Their work methods have changed as well because of the fact of COVID-19. What's also driving the innovation is the infrastructure costs. So effectively, we're going to talk about reducing infrastructure costs by using the cloud per se, and basically that sort of dovetails into the reducing the operating costs. And what's really driving a lot of this is basically trends using new technologies such as blockchain, IoT, artificial intelligence, as well as machine learning. So the challenges that we've seen is regarding COVID-19 and the climate. Effectively, the challenges such as the cybersecurity risks. So the cybersecurity risk has always been there, but a recent survey suggests that 54% of the utilities expect to be attacked by a cyber attack in 2020. And effectively, that was done in January, so pre-COVID. And so what happens with the COVID, when you add that into the equation, effectively, it becomes a little bit more prevalent because of the fact that you're having a lot more remote workers, and you have a larger surface area of attack. So you need to keep that in mind. Challenges in regards to the shrinking budget. With the shrinking budget, we see that because of the fact that there's a lot of the industries have been forced to either close, shut down short term, and basically everyone's working from home. So effectively what we're seeing is that the commercial use has actually gone down, whereas the residential use has gone up. But in turn, what you actually see in the overall is basically the revenue stream has declined because of that. And basically what affects that is basically the budgets then have shrunk because of that. Regarding the business continuity. During all this time, business continues to run. So effectively, everything has to continue on. We're also seeing differences in climate, such as forest fires. So basically, I'm located in Vancouver, Canada. We're having some forest fires near here. California is also seeing some forest fires as well. And you're also seeing some in the recent hurricane that's going to be hitting Louisiana and Texas. So effectively, you need to look at business continuity in these times where basically you have these natural disasters, as well as the climate change, which is affecting a lot of the way that we do business. And basically, utilities, they need to balance all these challenges, and basically this is a need for the digital transformation. So this is the agenda that we're going to follow today. So effectively, we're going to have a discussion regarding the cloud. And we've teamed up with AWS CloudEndure, as Carla has suggested, and they're going to outline a simple way that you can drive digital innovation and address challenges. So that we're going to talk about the cloud, and then we're going to address the challenges such as cybersecurity, trends, dangers, the shrinking budgets, which I've briefly discussed, as well as the continuity, business continuity, and reducing downtime, improving scalability. Okay, let's move into the cloud. So with the cloud, it's not just compute, storage, networking. Effectively, the major cloud vendors have been investing in new forms of compute, such as artificial intelligence, machine learning, as well as IoT. And basically, it's tying a lot of these components together so that you can use IoT as well as machine learning together, as well as the digital services and remote operations. So effectively, major cloud vendors, and such as AWS, they're actually investing a lot in these. And it takes quite a bit of infrastructure and cost to actually bring up, say, for example, an AI system or machine learning or an IoT. But effectively, with the cloud providers doing it, basically you just consume that service for them. So basically, you don't have to deal with the sunk costs that are associated with the infrastructure costs to bring up these new forms of compute. So when we look at a cloud-based disaster recovery can be seen as a first step towards cloud. So effectively, you can continue to run your on-premise applications and effectively have a disaster recovery within the cloud, so that when a failover occurs, it fails over to a cloud location. And effectively, it is quite a bit cheaper because of the fact that you don't have to invest in a data center on the opposite coast, for example, which falls into the next point, cost effective. Since there's no sunk costs associated with having to build a data center, having to find the land, invest the HVAC, power and cooling, networking, and all the compute, storage, and networking that's involved. Basically, the cloud provider provides that, and it's very flexible in the fact that you can consume what you need when you need. In regards to security, the cloud is very flexible, and it can be made highly secure. And what we've seen is basically, and you may have seen this as well. For example, the U.S. government, AWS has actually established 2 regions within the United States, one east, one west, and basically those are dedicated for the government. They're AWS Gov Clouds. Effectively, only government workloads can reside within there. Very strict, very stringent in the fact that only U.S. citizens can actually gain entry to it, and only as an as-needed basis. But effectively, what we're seeing is basically some countries and governments are basically looking as a cloud-first mandate. So basically, what AWS is doing now is putting these regions, what they call regions, and each region is devoted to, say, for example, Canada. There's a devoted Canadian region, and within that region, there's this construct which is termed as an availability zone, and that each availability zone is actually composed of more than one data center. So basically, a very resilient infrastructure. And we'll move on to the next. Basically, defining the CloudEndure is an easy first step. Basically, using CloudEndure, all the source volumes are actually replicated to an AWS region of your choice. Effectively, it does a block level replication from your on-premise servers and storage back to a region of your choice. Say, for example, you are located in the eastern region of the US. You can choose a region within the western region, such as Oregon or California. Effectively, you can replicate your blocks back there. So basically, you have that disaster recovery geographic separation. Because it's a block level replication, all your applications are kept up to date. And being that it is the cloud, it's fully accessible 24/7. And again, the region that you select as your target, it remains there. So effectively, if you choose, for example, US West Oregon, that's where your storage will be located that you're replicating, as well as that's where you'll be bringing up your target instance in the event of a disaster. So effectively, you choose where you want to run your infrastructure. And in the event that, and I'll leave this up to Chris, but effectively, if you like the AWS service, effectively you can then migrate your application if need be into an AWS region that of your choosing. So in regards to addressing key challenges, the recovery point objectives that CloudEndure allows, you can recover from a point in time that cyber attacks or ransomware occurred, so effectively improving your recovery. So Chris will talk about that as well in regards to the recovery point objective and the points that they can recover to. Regarding the shrinking budgets, using CloudEndure can lower your TCO based on your DR infrastructure, as well as the business continuity, reducing your downtime and data loss. Having CloudEndure can reduce that downtime. Not only is this your first step into the cloud, but it also addresses the key challenges that we've seen in regards to COVID-19. So let's delve into cybersecurity. So cybersecurity has always been increasing, but there was a recent survey that suggests that 54% of the utilities are expecting to be attacked within 2020. The NSA has released a bulletin basically telling the utilities basically to reduce exposure across your operational technologies and control systems. Ransomware has also increased as well. There's been an increase in malicious emails, and one company in particular, this email group, was attacked using this snake ransomware. In regards to the cloud, security seems to be a major barrier for utility companies to adopt the cloud adoption. It wasn't, the concerns weren't effectively around the vulnerability of the cloud, but the growing barrage of increasing sophisticated cyber security threats is the backing regarding that. So recovering from a cyber attack with DR, DR itself cannot prevent these attacks, but it can assist in the recovery. So effectively, there was a study done that 96% of companies with a trusted backup were able to survive a ransomware attack. Being unprepared in these instances take a huge toll on your business, but having a reliable backup can have a great success rate. Another another stat that was found was that $12 billion was lost by U.S. businesses per year due to data loss. But having a disaster recovery such as CloudEndure, they can help reduce that, effectively providing a trusted backup and good and multiple recovery point objectives, as well as a short recovery time objective could minimize this as well. So let's go over shrinking budgets. So these are some stats that were found. Effectively, $16.8 billion is estimated to be lost due to COVID-19. And again, this revolves around the fact that industries have been shut down due to the lockdowns and whatnot, and effectively everyone being working from home. Basically, the increase in residential use versus the commercial use follows on with the reduction in energy, effectively because of the fact that commercial is a larger consumer of electricity. Having everyone working from home, the residential usage does go up, but it doesn't offset the fact that the commercial has gone down by that much. And following on, because of the reduction in revenues, it's expected to see a 5 to 10% reduction in budget. All these issues, we still need, you still need to meet your customer demand for digital services, increasing the customer contacts and whatnot, optimizing the services that are offered to the customers, as well as maintaining cybersecurity in the event that these attackers, they don't take vacations because of COVID. They're probably more rampant. And of course, you have to launch new IoT projects. Traditional DR versus a cloud-based DR. As we all know, traditional DR, you require a new data center or a colo. You need your hardware, your compute, storage, networking. All that infrastructure needs to be acquired, as well as more of a CapEx version. For a cloud-based DR, with CloudEndure, as I said before, it does a block level replication, but it actually replicates into a low-cost staging area. So effectively, you're not replicating, say for example, you have 10 servers on one side, you don't replicate your 10 servers to the cloud. You actually replicate to a low-cost staging area where you have one instance basically doing all the replicating of the storage, and in the event of a disaster, a target environment is spun up. And Chris will go over that later in this presentation as well. And thusly, this reduces the compute cost by 95%, eliminating duplicated OSs and third-party application licensing, because of the fact that you're doing a block level replication and you're not actually spinning up the actual instances until you actually need them. And being that the cloud, you pay for only what you need. So let's talk about business continuity. So there's a lot of headlines here, effectively hurricane, fire, COVID-19. There has been quite a few recent weather-related disasters, forest fires, hurricanes, and they seem to be occurring more frequently and almost overlapping now. And a lot of companies have to really look at this and say, well, we have to continue our business during these trying times. With COVID-19, or the pandemic as people call it, there's still manual intervention required, such as to people who are on site, as well as the field crews. These workers can't work from home, and they're required to continue to either go in or work in the field. But now with the advent of this, there's also a push for having more remote monitoring and alerting using remote sensors. But effectively, there still will be an element of on-site workers or field workers, but more of a monitoring and alerting, so that you don't have to dispatch people as often, so to speak. Heat waves, rolling blackouts, those are happening. They've been happening quite a while now in the California area, and it's something that basically, as a utility, you need to look at. And with basically COVID-19, there has been a push for the workforce to move from home. Having these workers utilize tools that would have been used in a disaster. So basically, it almost this is almost a trial for a disaster. But basically, these workers are using more and more tools that would have been used during a disaster. So business continuity and digital innovation. The system critical functions, the operations, they're affected because basically on the site, you basically have redundant systems that has to be done. But the applications and other functions that may not be as resilient, such as customer service, retail operations, analytics, and remote workforce, they really need to be looked at as well, because ultimately those are revenue streams coming in. So as more services are moving online, there's more emphasis on business continuity and having that as a key consideration. So business continuity in the cloud, what it can offer, it can reduce your downtime and protect against data loss. Scalability, because it's a cloud, it can scale up and down as needed because it's a consumption-based model. Again, I talked briefly about this. It's more of an OpEx versus a CapEx, but effectively, if you run in a CapEx mode, there are strategies where you can actually make your OpEx look like CapEx as well. Accessibility, because it's the cloud, you can pick what region you want to operate in. So for example, like I said before, if you're running on the East Coast of the US, you can have your DR on the West Coast of the US, or maybe even in the middle, such as Ohio, but effectively it's in a different region that you are. And effectively, in the event that your on-premise systems are affected, you can run these disaster recovery locations in a location that's not affected by the disaster. And because it's the cloud, there's multiple locations that you can choose in each country of your choosing as well. And effectively, you don't have the sunk cost of a CapEx. But again, as I said, there are strategies that you can actually make OpEx look like CapEx. At this point, I'm going to pass this over to Chris, and he will continue on regarding the discussion for CloudEndure. Yeah. Chris? Sorry, Carla, go ahead.
Yeah, sorry, just jumping in there. We have had one question come through, and I don't know if anyone can answer this, but for old and conservative industries such as utilities, where they insist that they want their own thing, what kind of advice would you give to them? I think that that's speaking to, the sort of maybe more traditional view that utilities have, and maybe some sensitivity towards the cloud.
Yeah, so if they require their, quote unquote own thing, that's not necessarily opening up to the cloud. So effectively, if they're very stringent in the fact that they have to have their own infrastructure, there's not a lot you can do to get away from that, because effectively they're not quite adopting to the cloud at that point. That make sense?
Would there be potential, benefits or maybe advice around security in the cloud that you could potentially share with them?
I think I think you need to look underlying why they prefer that traditional stance, and address those issues. Like for example, if you said security, we can talk about security of the cloud and whatnot, but there are some underlying issues that has driven to that point where they want that traditional IT, and effectively we just need to uncover what those issues are, and if we can overcome those and offer a cloud solution.
Great, thanks. Sorry for jumping in there. I'll let you move on, Chris.
Okay, great. And thanks, Ray. I think it's a good segue into sort of drilling in on the technology itself. So again, I think Carla and Ray may have sort of introduced me at the beginning of it, but I run the specialized sales organization at AWS for CloudEndure, disaster recovery, for sort of the western side of North America. So what I'm going to do is sort of dive into what the CloudEndure DR specifically does from a technology standpoint, from sort of how it plays a part in an overall DR playbook, and then chat through some of those features. We'll run through the architecture. We'll try and keep it relatively high level without missing out on all the good points. And then we can sort of answer some questions at the end if there are any that come up. So when we talk about CloudEndure, we talk about data mobility. That's really where CloudEndure fits exclusively, right? So CloudEndure focuses on two very specific use cases. One is lift and shift migration. So taking workloads, whether they be on physical or virtual machines in a data center or in the cloud already, from a source and moving them to a target within AWS. So if we have a vCenter environment or a VMware environment, or a bunch of sort of homegrown applications and different highly transactional databases sitting in a colo, CloudEndure allows us to replicate that data into a low-cost staging area, which again I'll circle back to, and make those workloads available very, very quickly, very efficiently, and very simply. So again, I'll dive into those details, but from a use case perspective, migration is important to understand from the underlying technology perspective, because CloudEndure DR is the exact same thing, except we're not shutting down those source machines, right? We are keeping replication in place from our source, our production sort of mission critical environment, into a pilot light infrastructure within AWS that leverages really optimized, low cost, low compute resources to keep that up and running, and allowing us come that day where a true DR event takes place to spin those machines up very, very quickly. So again, I'd sort of mentioned that could be any physical machine or virtual machine. It could be sitting in a colo footprint, or it could be in headquarters, right? In the office, sort of in-office data center, or sitting in clouds like Azure or GCP or IBM. CloudEndure is an agent-based solution. So as long as we can install an agent on a Windows or Linux machine, we can essentially replicate it to AWS, given that the version of the OS is also supported. So where we see a lot of customers going with that is sort of the step one would be getting rid of disaster recovery data center footprints, or hardware is coming up on a refresh, or colo contracts are due to expire, and it's a really good time to sort of explore this new movement and adoption to the public cloud. And disaster recovery is a great sort of first step into that water, because essentially what we can do, is look at these workloads as a long-term perspective, a migration project, right? We can sort of understand what the resources look like, how do we manage those resources once it's in AWS, all through DR, and then come time which you actually want to cut those machines over. Again, the underlying technology is identical. We can actually just launch those machines like we would in a test, shut down the source, and we've effectively migrated. So it's very, very important to sort of understand that as I run through the architecture and the features, is that a lot of our customers leverage sort of the 1 to 5 year plan of protecting mission critical machines, with the end goal being to migrate at some point. And then look at things like cross-region or cross-cloud resiliency, where you still have that geographical diversity, but it could be maybe from one cloud to another, or one region within AWS to another geographically diverse region. I mentioned that CloudEndure is essentially application agnostic. We don't care what's running on those machines most of the time. The reason for that is because we're running block level replication at the OS level. So again, as long as it's a Windows or Linux machine x86 and the version of that OS is supported by AWS, CloudEndure will be able to make that data available in the target AWS infrastructure. Okay, so I'll dive into some of the details here from a feature perspective. I talked about the flexibility. There's sort of two other components about CloudEndure that make it unique versus maybe some of the other disaster recovery solutions or technologies that you may or may not be familiar with. One of them is that we're OS-based block level replication. So we're not doing everything at the hypervisor level or at the SAN level for that matter. We're taking the entire stack, right? So the OS, the applications, the databases sitting on it, the agents that are installed. We're taking that workload and the attached storage to each one of those machines, replicating it and launching them exactly as is on source in the target. However, we are able to convert those machines from the dissimilar infrastructure that it may be sitting on in your home data center into AWS, the AWS language, or the AWS version of that machine within seconds. So we can essentially take a physical Linux box and convert that into what we call an EC2 instance with backed EBS storage, all within just 30 seconds to a minute. So from an RPO and RTO perspective, sort of the 6 letters of disaster recovery, recovery point objective and recovery time objective. When we talk about recovery point is the point in time that you need to recover back to. So whether that be a minute ago, 4 hours ago, a day ago, that's what we consider a recovery point. And since we're doing block level replication in real time, we have a sub-second recovery point capability. So as the last data that was pushed or written to disk at the source is immediately transmitted into this pilot light infrastructure, and that recovery point is actually available to be spun up in near zero data loss. From a recovery time perspective, the amount of time it takes to actually launch those machines once you initiate the command. CloudEndure has the capability of pretty much launching any size machine that's in continuous protection, anywhere between 4 minutes and 15. So sub-second recovery points and recovery times of minutes. So depending on sort of what your DR requirements are, your recovery strategies may look like, it's very important to sort of keep in mind what those recovery point and time objectives are, define them, and make sure that it's tested frequently. Which leads me to sort of the last piece of the features, and that's that CloudEndure allows you to essentially test and run DR drills on a regular basis and validate that the technology is going to work exactly as expected. That's speaking to the AWS flexibility, right? So the on-demand resources at your fingertips whenever you need to launch those machines, and the ability for CloudEndure to sort of do that in an isolated fashion. Okay, so what I'll do now is sort of just run through the architecture from install to launch, and I think this paints a pretty good picture from a high-level perspective of how CloudEndure operates. So on our source machines, right, that could be sitting physical, virtual, or cloud-based, we are going to install an agent on those machines. The agent sits about 300 megs in memory and generally consumes on average about 5% of that machine's CPU. And what that agent's going to do first is make a handshake with the CloudEndure user console or management console. It's a SaaS console that just acts as a control plane for the provisioning process and sort of the orchestration. It sits on AWS. And that handshake only entails essentially the agent providing CloudEndure with some details about the machine. So metadata, the machine name, machine ID, RAM, CPU, the number and size of the volumes attached to it. Outside of that, no data actually passes through CloudEndure, right? So we just take that information in order to provision what we call a staging area. So we'll identify your account within your AWS footprint with the account identifier, an access key, and essentially provide CloudEndure with programmatic access to spin up resources. And with that, CloudEndure will automatically manage and provision this entire staging area creation and management on an ongoing basis. So what happens when we do this, in this example, we have 2 VMs, let's say, with 5 volumes attached. In the staging area, we are going to spin up 5 low-cost storage volumes, and we are going to spin up a single EC2 instance. Now, the ratio for that, sort of where we see that total cost of ownership reduction versus maybe a 1-to-1 mirrored infrastructure in a data center, is for every 15 volumes, we only need to spin up 1 very low-cost compute instance to act as a replication server. So it receives the agent traffic and disperses it amongst those volumes. So low-cost storage, low compute resources, and this is what we call our pilot light scenario or staging area. So that agent will go through an initial syncing process, and then once it essentially pushes all that data or seeds all that data, it'll move into continuous data protection mode, or CDP, where the agent just sits in the IO path and acts as a write filter. So whatever data is written to disk or committed to memory is immediately pushed across the internet, a direct connect, VPN tunnel, sort of there's flexibility and preference there, directly to this staging area. Encrypted in transit, and you have the ability to encrypt it at rest. This is sort of the day-to-day cost, and this is what's taking place on a regular basis until you're running a drill or a true DR event takes place. At this point, we are able to now begin testing or begin launching these machines into actual, production quality workloads. But first, we need to create something called a blueprint. And what the blueprint is essentially is it defines the machine's profile, right? So how much RAM and CPU does it need? Let's tie that to a certain type of AWS EC2 instance. Subnet security groups, IP addressing, storage tags, what type of storage those machines require. And the blueprint can be done in a number of automated ways with APIs and sort of third-party discovery tools. But once we have those blueprints created, we can then start launching these machines. Effectively, this is sort of going back to those two pillars I was talking about earlier with machine conversion and automated orchestration. When you select machines to launch, CloudEndure will go through the process of converting those machines into production-ready type of storage disks. We will spin up a machine converter, which again is just an EC2 instance, for about 30 seconds to a minute. And it runs all of the OS activation changes, boot process changes, guest agent installs, essentially everything that needs to take place in order for that machine to be bootable on the AWS side. That machine converter is then automatically spun down and removed, and we mount those volumes on the EC2 instance as defined in the blueprint, so onto the compute instance. Again, from a recovery point perspective, we can select the latest, which is sub-second, and then a number of recovery points dating back anywhere from 1 day to 90 days. So when we talk about ransomware, cryptovirus, any sort of malware where you don't want to fail over to corrupted data, and maybe you found out about ransomware on some of your critical machines after a long weekend, you can fail over to 5 days ago to healthy data. So you have that recovery point flexibility based on retention policies. And then from a recovery time perspective, we're spinning these machines up, no matter the size, anywhere between 4 minutes and 15 minutes. And the reason for that is because we are sitting on the AWS backbone. We are exactly where the data is already residing where you're launching it. And we're essentially just running that conversion process and booting up a machine. So I want to sort of take a pause here and go back to that migration topic. If this was a true DR drill, which we've seen with customers like Malibu Boats, who had a massive DR event about 2 weeks after installing CloudEndure, they failed over their entire infrastructure. They were up and running again, sort of after all the user traffic sort of got sorted out within an hour. And they realized that some of their largest applications that were sort of struggling on-prem were actually performing about 50% better in AWS. So they actually just left those machines there, shut down the source production instances, and then failed back all the rest of the environment until they were sort of more prepared for it, but left those resources or those workloads in AWS moving forward. So they actually treated it like a lift and shift migration. And CloudEndure DR allows you to do that sort of as an additional feature or benefit. Now, if this was just a test or a drill, we can validate this, let our application teams come in and say everything works, delete these target instances, and again, we are no longer paying for production resources anymore. We are only paying for that low-cost storage and low compute instances in the staging area. So from a TCO perspective, we are optimizing both costs and resources that are required without giving up on any sort of capabilities from a recovery perspective. And that is essentially CloudEndure. So I'll hand it back to you, Rare. We can field some questions. Carly, it's sort of up to you.
Yeah. So just while Ray's kind of getting his slide deck back there, I have one question. A lot of utilities, critical infrastructure providers are in, highly regulated industries. And I noticed you were talking about target regions. Can you speak to like data sovereignty, particularly in Canada? That's a hot issue.
Yeah, very familiar with it. So whatever regions that AWS has or supports for the most part, I think China might be still, there's some exclusions there. CloudEndure does as well. So CloudEndure was acquired by AWS about almost 2 years ago now. We're going to become a native service, so we'll be directly tied into the AWS console. But essentially our roadmap is in parallel or directly tied to the AWS backbone. So if there's compute and storage available in the Canadian region, CloudEndure can replicate there as a target. And it would stay within that sort of availability zone, which is a cluster of data centers in a somewhat geographical like region, and they replicate within each other as well.
Okay, so I'm just thinking like you could, if you're a utility, you have an enterprise application, you want cloud-based disaster recovery for that, I'm thinking mainly in Canada because that's where I'm located.
Mm-hmm.
You're fine to do that and also comply with any specific data residency regulation.
Right, because we're replicating it within country, just to essentially a different building on different infrastructure into the AWS regions.
Great, thanks.
Mm-hmm.
Chris, can you stop sharing, please?
Oh, yep, my fault.
Thank you. Thanks, Chris.
Thanks. I'll just give people a couple of seconds to send. If you want to send a question in, you can put it there in the Q&A, or you can also drop it in the chat if that's more comfortable. I'll see that as well. In the meantime, I think Ray's just going to go through his last few slides here.
Yeah, so thanks, Chris. So we have the FuseForward disaster recovery product, and it's basically built off of CloudEndure. So what we do is we do all the cloud part for you. So basically it's a fully managed service. We'll set it up, we'll monitor, and we'll test all your AWS recovery environments and provide 24/7 support. So effectively, if you still are within the on-premise mentality and you want to do a cloud DR, we will do all the components that are required within the cloud. So basically, we will need you to install the agents, but we will set up all the environment within AWS, have your target environment set up within AWS. So basically, you don't have to do all that cloud knowledge if you don't have it. As Chris was alluding to, cost effective. You only pay for your full recovery when you need it. So going back to Chris's diagram, you're paying for the low-cost compute, which is actually used as the replication, and then you also pay for the low-cost storage, which is being replicated from your on-premise site. You don't pay for your target instance. You're effectively the mirror of your production until you actually test or when you actually fail over. This is highly secure, as Carla was alluding to in regards to data sovereignty. All your data can stay within, the said country that you reside in. We can work with you in regards to if need be, if you want private networks. So, for example, you want a private network to AWS just for this. So basically, all your network traffic otherwise would go through a VPN through the internet. It is encrypted in transit and at rest, but effectively, if you want a private network, we can help you do that, such that we can get you set up with a private network to tie into the AWS backbone, and then directly to your instances within AWS. So effectively, we can comply with that security that you're looking for as well. And that's my last slide, and we can move into the Q&A. Carla, is there any questions?
I don't see any coming through. I think everyone's done a pretty good job of explaining there. Yeah.
Okay,
Thanks,
I'll
everyone. We
advance
can
to the
move on.
next one.
And
so thank you for attending the webinar, and there's a special offer for you. FuseForward can provide a free assessment. Effectively, we can offer, with CloudEndure and AWS, we can offer 50% off of your AWS spend. as well as the CloudEndure licenses can be free until the end of 2020. There is a link on the bottom of the slide. Basically, it's a DR assessment. So if you can go out there and you can subscribe to that.
Yeah,
Carla, is there any
yeah, I'm
questions?
just going to jump in. So that disaster recovery needs assessment, if you want to go there, you're interested in disaster recovery, Edric shared the link and you can sign up. We'll contact you and we'll determine, what, and I'm getting a little bit out of my area here, but what the benefits of a disaster recovery system will be for you. So for example, like your potential cost savings, you can use that to make a case for disaster recovery. And the AWS spend, the 15% off there, that relates to CloudEndure. Just wanted to make that clear. But I've just got another question here. Somebody asking, will this session be recorded? Definitely will be. I'll be sharing the recording afterwards. And we'll also be reaching out with an email following this session that includes details of this offer, how you can sign up. Yeah, so that's all I had to add there.
Okay, I'll hand it back to you, Carla, then.
Okay, great. All right, so thanks for joining us this morning, everyone. It was great to have you all on for this session. This session is actually part of a series, Remote Control. So we do a different topic around either remote operations, analytics, IoT for critical service providers. So, focusing on energy and infrastructure, other industries like education, sometimes they're interested. But you can subscribe so you're always notified at the link here. I believe Edric is also sharing that. Also follow us on LinkedIn, Twitter. Love to see you there. We're always sharing industry related information. And another thing we've started recently is a meetup group. So it's not on this slide, but if you're on Meetup and you want to stay up to date with what we're doing, you can join us there. So yeah, a lot of ways to stay in touch with us. And as I mentioned earlier in the chat, you're also welcome just to drop us an email if you want to discuss anything from this session. So I think that brings us to the end. I'm just looking at the Q&A. Doesn't look like any new questions have come through. So I'm going to save us all a little bit of time and wrap this up. Thanks for joining, and thanks Ray and Chris and Daniel for presenting.
Thank you, everybody.
Yep. Cheers, everybody.